Welcome to part 1 of the Beat Sequencer Unity tutorial by PeerPlay. In this first part we are going to create a BPM counter so that we can apply behavior timed on the beat. This tutorial is made possible by the support of the amazing patrons at my Patreon. Special thanks to Andrew Laboy, Devin the Dude and Fegter. In this first part we are creating 3 different scripts. First we're going to create BPM, in which we'll calculate the beats per minute. Then I will show you how to create a simple sound manager so that we can play different sounds without worrying them to be cut off by a new sound playing. We will then use this sound manager to play sounds on the beat, and for this example I recorded 5 different sound effects with my guitar that we will play on the beat to create a little pattern. The first sound is going to be the tap on guitar. The second sound is my nail on the guitar, a G chord, and a D, and a C chord. You can hear the resulting pattern at 60 BPM when I play the scene. If I change the BPM to a higher beats per minute, like 100, and I play the scene, it will play faster. We'll start off in a new empty project. I already included the guitar sounds folder, and if you want to use these samples, you can get them as a patron on my Patreon. So let's create the BPM class. So create C# script, and we'll call this BPM. Now let's create an empty game object to put the BPM class on. So create empty, and we're going to rename this to BPM. Let's drag and drop that BPM there, and let's open up the script. Now the first thing we're going to do is to make sure that there's always only one BPM class. So to do this, we're going to create a private static BPM, and we'll call this the BPM instance. Now we're going to create a private void awake. So a private void awake. And in the awake function, we're going to set this script to be the private static BPM. So if the BPM instance is empty, it's going to be this script. And if it's not empty, we want to remove this script. So we're going to say an if statement if the BPM instance is not equal to null, and if the BPM instance is not equal to this, then we're going to destroy this object because it already exists. So we're going to say destroy this dot game object. Now else we're going to set the BPM instance to become this. And we're going to set the don't destroy on load of this dot game object. So it's not going to be destroyed, and it's always there because some scripts will reference to the script. So we want to make sure that this script is always present. Now let's save the script and test this out. So go back to Unity. So we've got the BPM class here, and if we run this, you can see that it's under the don't destroy on load, so that works. Now if there are multiple BPMs, let's create a few more. Let's see what happens. When the application is run, it will destroy everything but one and keep one alive. So that's good. Let's continue. So we're going to create a beats per second calculator. So for that we need a new variable. So let's create a public float, and this is called the BPM. So we can set the BPM in the inspector. Now let's create a few private floats. We'll need a float that's called the beat interval. We'll have to calculate that. And we're gonna need a beat timer. Now we also need a boolean. So let's create a public, and we're going to create a static bool. And we're going to call this the beat full. And we'll also need a public static integer, and we'll call this the beat count full. Now I made these two variables static so we can access them from any script in our application, and because we know that there's only one BPM, we can use these. Now let's write out a function using these variables. So let's go under the update and we're going to set a new void and we'll call this beat detection. And we're going to call the beat detection in the update. So this is going to be about the full beat count. Now at first we're going to set the beat full boolean to become false. What we want to achieve is that in the frame that there is going to be a beat, the beat full will be set to true, and the next frame the beat full will be false again. So we can do a check on this boolean whether there is a beat or not. So let's set the beat interval. So we're going to write the beat interval, and that is going to be 60, which is an entire minute, divided by the BPM. So if the BPM would be 60, 60 divided by 60 is 1, so every second there will be a beat interval. Now if the BPM is 120, it will be a half of a second, so every half of a second there will be a beat. So in the update we're going to increment the beat timer with the time.delta time. Now we need to check if the beat timer is above or equal to the beat interval. So let's make an if statement, and we're going to say that beat timer is higher or equal to the beat interval. Now if that is true, we're going to subtract from the beat timer the beat interval. Also, we're going to set the beat full to become true, and we're going to add 1 to the beat count full. So plus plus, because it's an integer. So now we have the full beat, but I also want to do the same on the eighth of the length of the beat. So we're going to divide the beat by 8 and do the same as we did with the full beat. So let's go to the top and create a few more variables. So at the private floats, we're also going to add a beat interval divided by 8. And we'll also create a beat timer divided by 8. Now instead of the beat full, we're also going to add a beat divided by 8. And we're going to add a beat count divided by 8. Now let's implement those in the function as well. So let's scroll down, and underneath this if statement, we're going to say that this is about the divided beat count. And here we're going to say that the beat divided by 8 is going to be false. And the beat interval divided by 8 is going to be the beat interval that we already calculated divided by 8. Now the beat timer divided by 8 plus is time.delta time. And we're going to do another if statement. So if the beat timer divided by 8 is higher or equal to the beat interval divided by 8, then we're going to set the beat timer divided by 8 minus is the beat interval divided by 8. We're going to set the beat divided by 8 boolean to become true, and we'll add 1 to the count of the beat divided by 8. Now that's everything to calculate the BPM, but to test this out we can also do a debug.log. So let's do a debug.log, and we'll log here divided by 8. Now let's copy and paste this into here, and we'll call this a full. Let's save the script and go back to Unity. Now back in Unity we still need to remove all of these BPMs, so let's keep 1, and we're going to set the BPM. So let's set that to 60. Now we should see some debug.logs every second of the full and 8 times as more of the divided by 8. There you go. Each second this will add 1, and this is going 8 times as fast. So that's all working. Now let's continue by creating the sound manager. So let's go to create, C# script, and we'll call this sound manager. Now let's create an empty game object, and we're going to call this the sound manager. And let's drag and drop this sound manager onto the sound manager object, and let's open up that script. Now let's create a very simple sound manager. So we're going to say public integer, and I'll call this the bank size. Now let's create a private list, and this will be a list of audio source, and we'll call this sound clip. Now this sound manager will spawn a list of sound objects that we can use to play anything. If all the sound objects are already currently playing, we want to create a new sound object so that the current playing sounds aren't cut off by a new sound. So in the start function, we're going to say that sound clip is going to be a new list of audio source. There we go. Now let's create a for loop. For int I is 0, I is less than the bank size, then I is going to be plus plus. So based on the size of our bank at start that we can set in the inspector, we're going to instantiate some game objects. So let's say game object, and we'll call this the sound instance is going to be a new game object, and we'll call this sound. Now the sound instance, we want to add a component to this. So we're going to add component of a audio source. Now we want to make this sound instance a child object of this transform. So we're going to say sound instance dot transform dot parent is going to be this dot transform. Now we want to add the audio source of the sound instance to the list. So we're going to say that the sound clip dot add is going to be sound instance dot get component audio source. Add that to the list. Now we don't need the update. We are going to write our own function, and we're going to call this a public void, and we'll call this play sound. And this will require two different components because we can call this from in our script, and we want to get an audio clip. We'll call this clip, and we also want to set the volume of that clip. So let's set a float, and we'll call this volume. Now in this function, we're going to look for a sound clip that is not currently playing. So let's do a for loop. For int I is 0, I is less than the sound clip dot count I plus plus. Now if the sound clip of its current position in the loop is playing, and we want to check if it's not playing, so let's put an exclamation mark in front of it. If it's not playing, then we want to set the sound clip of its I position, its clip, to become the clip of this function. Now we also want to set the volume, so let's get the sound clip of its current position dot its volume is going to be volume, and we want the sound clip to play, of course. So let's say sound clip current position dot play, and then we want to break out of the loop and the entire function, so we're going to say return. Now if this function hasn't found any clip that is currently not playing, then we want to create a new instance of a sound clip. So let's copy paste these lines here and paste them outside of the for loop, and we need to set the clip and volume and play as well of the sound instance audio source. So let's say sound instance dot get component, and we're going to get the audio source, and we're going to set the clip to become clip. Let's copy paste this here so I don't have to type it again. Dot volume is going to be volume, and we also want to set this to play. Now that's all for our sound manager, so let's save this script and go back to Unity. Now in the inspector we can set the bank size, so if I set it to 10 and I play the scene, and you can see that it has created 10 different instances of a sound object. Now that we have created our sound manager, let's create the third script that we need. So let's go to create C# script, and we're going to call this play sounds on beat. Let's create an empty game object and we'll call this play sounds on beat. Let's add the play sounds on beat to this object and let's open up the script. Let's start by creating a reference to our sound manager. So I'll say public sound manager is going to be the sound manager. Let's also add the audio clips that we need. So public audio clip, and I'll call this clip tap, and I'll call this one tick. Now for the guitar strumming, I've got 3 different audio clips. So we're going to create an audio clip array, and I'll call this strum. Let's create a random strum, so I'll create a random strum integer. Now let's make the audio clips play on the beat. So in the update, we're going to do an if statement, and we're going to talk to the BPM, which is a static class, so we can exit it from this class. So we're going to get the beat full. So if the beat full in this frame is true, then we want the sound manager to be playing a sound, and in here we need to get the clip and the volume. So we want to use tap, and we'll play it at volume 1. Now for every 2 beat counts, I want the strumming pattern to change to a different chord. So inside of this if statement, we can create a new if statement, and we'll talk to the BPM, and we'll get the beat count full, and this beat count is counting up and up and up. So we can do a modulo on that, and if it's 2, then it's going to be 0 again. So modulo 2, if that's equal to 0, so every 2 beats, then I'm going to set the random strum to become a random.range between 0 and the strum.length of the array. Now I want the tick to play 4 times the speed of a beat. So for each beat, the tick will play 4 times. So we're going to create an if statement, and we'll talk to the BPM again, and we'll get the beat divided by 8, if that is true, and if the BPM dot beat count divided by 8 is modulo 2, and if that's equal to 0, then we're going to talk to the sound manager dot play sound, and we're going to play the sound of tick, and we'll play that at 0.1 volume. Now for the strumming, I want to play the strumming at the 2/8 and 4/8 of a full beat. So to do that, we're going to type an if statement again to the BPM dot beat divided by 8, if that is true, and if the BPM dot beat count divided by 8 modulo 8 is equal to 2, and also to 4. So put a AND value there, and we're going to copy paste this and change this to 4. Now we want to talk to the sound manager again, play a sound, and the sound we want to play is the strum. And which one do we want? We want the random strum that we've selected, and we'll play it at the volume of 1. So in this script I hard-coded the pattern, but later on in the tutorial we will create a beat sequencer. So let's save this script and go back to Unity. Now in Unity, let's drag and drop the sound manager onto this slot. Go to the sounds, and we gotta get the tap, the tick, and the different chords in the strum array. No, not 30, I want 3. So C, D, and G. Now let's test it out by playing the scene. That's it for this tutorial part. In the next part we will create a beat tapping system. But for now, thank you for following this tutorial part. If you would like to get updated with new release tutorials, subscribe to the channel and turn the notifications on. To support me creating these tutorials, you can become a patron at my Patreon. You then get access to this full tutorial, source files and extra content.